We saw in an earlier tutorial that when a polynomial p of x is divided by ax plus b, then p of x can be written in this form here, where q of x is the quotient and r is the remainder. Is it then possible to find the remainder without going through the whole division process? This is the question that we are going to try and answer in this tutorial. If the divisor ax plus b is equal to 0, then this product 0 multiplied by q of x is also going to be 0, leaving us with r on the right hand side. Now we just need to find the value of x that will make this term equal to 0. So if I go ahead and say if ax plus b is equal to 0, then if we solve this taking b to the right hand side and then dividing by a, we will find that x is equal to negative b over a. Thus p of x, and we found that x is equal to minus b over a, is going to be equal to a multiplied by the x minus b over a plus b multiplied by q of x plus the remainder r. Now if we go ahead and simplify that, we're going to get the a's will cancel out, so in that bracket we'll have minus b plus b multiplied by q of x, your quotient, plus your remainder. Now you will have minus b plus b being equal to 0, and 0 multiplied by q of x, then it is going to be equal to r. So r is equal to your remainder. So what we have actually shown is that if we can find some value of x which will make the linear divisor equal to 0, then the remainder is going to be given by p of that value of x. In that same earlier tutorial, we also found that when x cubed plus 2x squared minus 3x plus 1 is divided by x minus 2, we got the quotient to be equal to x squared plus 4x plus 5, and we obtained a remainder of 11. You can see that if we insert 2 in this divisor here, this bracket will go to 0, and then we'll have 0 multiplied by the quotient, which is going to give us 0, and 0 plus 11 is going to be 11, which was our remainder to start off with. Now if I call this polynomial p of x, and I know that it's equal to x cubed plus 2x squared minus 3x plus 1, and we want to find the remainder when this polynomial is divided by x minus 2. So without going through the whole division process, I could use the remainder theorem, which states that we must first of all set our divisor to 0. So x minus 2 should be equal to 0. It follows that x is equal to 2. Now we have seen that the remainder theorem says that the remainder is going to be given by substituting this x value into p of x. So if I find p of 2 then and substitute into p of x, we will have 2 cubed plus 2 multiplied by x squared, which in this case is going to be 2 squared, minus 3 multiplied by 2 plus 1. Simplifying this will give us, this is cubed. Simplifying this will give us 8 plus 8 minus 6 plus 1, which will then be 16 minus 5, which is equal to 11. And you can see that this is the same remainder that we found when we divided the polynomial using the identities. So to recap, when you want to find the remainder when a polynomial is divided by a linear factor, what you will first do is equate that linear factor to 0 to find the x value which will make the divisor equal to 0, and then you substitute it into the original polynomial, and the constant that you obtain is going to be the value of the remainder. The factor theorem is an extension of the remainder theorem. It states that when a polynomial p of x is divided by ax plus b and the remainder is 0, then ax is a factor of p of x. Alternatively, if ax plus b is a factor of p of x, then what we are saying is that p of minus b over a is going to be equal to 0. So if this is a factor of p of x, then this must be true. I'm now going to take you through 3 questions that will help to reinforce these ideas. The first one requires us to find the remainder when 2x squared plus 3x plus 1 is divided by 2x minus 1. You will notice that I'm not asked for the quotient here, so I'll go ahead and set the divisor to 0. So 2x minus 1 is going to be equal to 0, and solving this will say that x is equal to 1 over 2. Now by the remainder theorem, we know that the remainder is going to be equal to, if I call the polynomial p of x, it's going to be equal to p of 1 over 2, which I'm going to substitute into that expression. So it'll be 1 over 2 squared plus 3 multiplied by 1 over 2 plus 1. Simplifying this should give us 1 over 2 plus 3 over 2 plus 1. And you'll find that the remainder is equal to 3. The second question is shown here. It says that when x cubed plus 2x squared minus qx plus 1 is divided by x minus 1, the remainder is 5. Find the value of q. Again, we're going to set the divisor to 0, so x minus 1 is equal to 0, and solving this is going to tell us that x is equal to 1. Now by the remainder theorem, we know that p of 1 must be equal to the remainder, which is given here as 5. So p of 1 should be equal to 5. Now if I go ahead and substitute this value of 1 into the polynomial, we will have 1 cubed plus 2 multiplied by 1 squared minus q multiplied by 1 plus 1. Now when we solve this, we'll have 5 is equal to 1 cubed is equal to 1 plus 2 plus 1 minus q. Now this is going to be equal to 4, so 5 minus 4 is equal to negative 1, which is equal to, that is equal to positive 1, which is equal to negative q. So q will be equal to negative 1. Okay, the final question is given here. It says that the cubic polynomial x cubed plus ax squared plus bx minus 8, where a and b are constants, has factors x plus 2 and x plus 1. Find the values of a and b. Now we know that x plus 2 is a factor of this polynomial, so using the factor theorem, I know that if I find a value x plus 2 is equal to 0, it follows that x is going to be equal to negative 2. Now plugging this value of x into the polynomial, I will have p of negative 2 being equal to negative 2 cubed plus ax squared, but a is equal to negative 2, so I'm going to write that as squared, plus bx minus 2 minus 8, and that should be equal to 0 since x plus 2 is a factor. Now simplifying this will give us minus 8 plus 4a minus 2b minus 8 to be equal to 0. Now you will agree with me that this will simplify to 4a minus 2b minus 2b is equal to positive 16. Now dividing throughout by 2, that will give us 2a minus b is equal to 8. Now I cannot solve this equation because it's got 2 unknowns there, so we must be able to find another equation using the information that we're given in the question. We already know that x plus 1 is also a factor, so I'm going to set that to 0. So let me just say also x plus 1 is a factor, so is equal to 0. It follows that p of x is equal to negative 1 is also going to be equal to 0. So p of negative 1 is equal to 0 since x plus 1 is a factor. Now this is the same reasoning that I used here. Now if I do that and substitute the 1 into the polynomial, you will get minus 1 cubed plus a x squared, in this case it's minus 1, plus b minus 1 minus 8, and that has to be equal to 0. Now simplifying this gives me minus 1 plus a minus b minus 8 is equal to 0. This implies that rearranging this equation will give you a minus b is equal to positive 9, and I will call this equation 2. Now solving this by elimination, I'm going to write equation 2 beneath this, equation 1 beneath this equation 2, and it's going to read 2a minus b is equal to 8, so that's your equation 1. If I minus the two equations, that should ensure that I will be able to eliminate the b. So minusing those two together, I'll have a minus 2a, and that is going to give me minus a is equal to 9 minus 8, which is equal to positive 1. So it follows that my a is equal to minus 1. Now then, taking this value and plugging it into equation 2, it follows that minus 1 minus b is equal to 9, and so minus 9 minus 1 is equal to b. So b will be equal to negative 10. This is how you would make use of the factor theorem to solve a question of this form. This brings us to the end of our tutorial. Thank you for watching, and we'll see you in the next one. Cheers.